section where we're going to be doing the training on the curation of the data. So this way, everybody gets a little bit of some familiarity with the overall concepts, and then a little bit of practice on what we're trying to do in regard to curating some of the underlying protocol data. So you'll all remember when we met in the last introductory meeting that this is around interest around stem cell biology and is a Nobel Prize winning discovery that has been quite transformational for us to understand how cells differentiate into different cell types and the ability to make different cell types of the body, a human body in particular, creates huge opportunities for us to study how different organ systems develop and also to model diseases and discover new therapeutics. So the underlying focus of this project is around understanding how induced pluripotent stem cells can be used in their different applications for a range of different purposes. But ultimately, in order for us to be able to make good use of them in these kind of endpoint assays, we actually have to figure out how to go from a pluripotent cell into a cell type of interest that can be fed into any of these endpoint studies. And this is a big challenge because everybody has different opinions about how to do that, and we're trying to find a way to curate that information to help us more effectively derive the cell types that are most useful for us to do these different studies. So in the current study, what we're going to be focusing on is cardiovascular development, which is where my lab's focus is. And I'm sure that you guys in probably your high school courses or even undergraduate or wherever have had a little bit of familiarity or some teaching around the process of heart development. But this is just a very basic schematic that walks you through that process during this kind of early developmental process where cells make different cell types of the heart, including the atria and the ventricle, in this initial cardiac crescent shape. And then they create, ultimately, over the course of just a couple of weeks, a four-chambered heart that has atria and this outflow tract where the blood gets pumped out to the rest of the body. And then blood gets pumped into the heart and circulated through the lungs, etc. So ultimately, the ability to make a cell go from an undifferentiated state and guide it through all of these complex processes, ultimately to create a cell type that is something functional, that's at least similar to what we have in the adult heart, is what we're trying to achieve. And that's ultimately what stem cell differentiation is all about. Now, if you go back and look at different studies that my lab has done in the years past, we've made cell types of different parts of the cardiovascular system, including the beating heart muscle cells up here on the left that can generate force. And they make these beautiful sarcomeres in their cells that are part of the contractile apparatus. But we also can make cells of the vascular system, and this is like a vascular network here where we differentiate the cells into the endothelial cells, and they make these beautiful networks that can form tubes in a gel. Just like the cells would form a tube when they're being formed into the blood vessels of your own body. And they intrinsically know how to do this, which is really quite a remarkable task. And then on the far right, you can see the cell types of the hematopoietic system, different blood cell types. And so it's just all about the cues that we give them. They all start out the same. The cells are undifferentiated on day zero, and then by giving them one cue after the other over the course of time, they're receiving the types of information that are required to tell them, or at least instruct them, to make a heart muscle, or make an endothelial cell, or make a blood cell. And these are the cues that we're trying to learn in order to do this most effectively. And so in this context, I wanted to just give a bit of a simple design or what differentiation is like in the context of a workflow. So at the beginning on the far left, we have pluripotent stem cells. And these are undifferentiated. That means that they can make any cell type you want. They could make the brain, the liver, the heart, whatever they want. This is the cells that we're maintaining in the incubator. And now we have to try to figure out how to basically kickstart the process to make them turn into some kind of definitive cell type like a cardiomyocyte that has some function. So, in the process of this, there are a lot of different factors that are added in a particular order. They have to be added in specific time points in order for the cells to get the right instructions that allow them to understand how to go from the beginning to the very end. And these things have to be put in exactly the right order. You can't shuffle these things around. And so when we're reading protocols, which we're going to be going through in the next little bit, you'll be watching for indications of when factors are added. So on day zero, we added, something like Chiron 9901 for 2 days. And then that was switched out for IWR1, which was used or added on day two, between day two to day five. And then that was changed out for something else that was used to culture them out for the duration of the protocol. So a lot of different labs will have different ideas about what needs to go in what order. And a lot of different protocols have been derived that are different labs will use different protocols for different reasons, and that's what we're trying to curate. Is we're trying to get the information from one study or the other, what is added at what time points, in order for us to be able to get to the very end of the protocol, and what does that make? So this is a bit of a busy slide, but don't worry about reading it up in too much detail. But it's the same kind of concept where we've got a time, a day here, day minus 4, 3, 2, 1, and then 0 is the day when you kick them off, and they're differentiating into cardiomyocytes. And by day, 13 or so, we've got the end of the protocol around this time. But as you can see, for each of these rows, it's a different protocol that we've kind of annotated here for our own purposes. But you can see that for this first one up here, there's different factors than there are in the second protocol or the third protocol. You can see that there's changes in what the factors are, how long they get added in, and where things go. And this is what we're trying to curate in the databases for any particular study. When you look at the time of differentiation, what are the factors that are being added, and how does that affect what cells are being derived at the very end? So that is a crash course on what we're trying to do here in regard to the underlying biology of stem cells and what the overall vision is. Here we're only, say, looking at 13 or so or 16 different protocols, but there are, as many variations on this as you can imagine when we're looking at hundreds of studies from all over the world that have been doing this for the past 2 decades. Everybody's changing this and that. So we need to try to bring it all together in a way that allows us to learn in efficient ways what we've got out there in the field so that we can make better use of that information more effectively for understanding stem cell differentiation. And that can only happen when we actually get these kind of curated data sets. It's going to be an extraordinary resource for the field, and we're excited to have everybody participating in this. So what you will have received in the email was this stem cell paper, which is the one that you're going to be working on today in your practice filling in the database. So you'll have received a spreadsheet in order to fill that in. So online, we've got Chris Chow and Nick Cow, who are the leads in my lab on this project. And we're going to shift gears now to start to give you a little bit of a sense on how to fill in the database. The one thing I do remind you all about is this is an experiment for us in working with you to try to understand how to train you in how to fill in this database, because we recognize that most of you, if not all of you, have never worked with stem cells or understand the underlying biology. So it's a bit like throwing you into a French course to tell you how to speak French. Like it's a bit of a learning process, and we have to take it one bit at a time. So bear with us as well in the process. We welcome your feedback if we're moving too quickly, but hopefully we're able to provide this one step at a time as we get underway with teaching you guys how to do this. So for right now, I'm going to hand it over to Nick, who's going to walk you through an example method, and then we'll shift gears in the later part of this to let you guys do your own on this particular study that we sent out.
All right, yeah, we can see the database now. So basically, the database, if you can see from the left to the right side on the first row, displaying as units, nodes, and different days of differentiation until day 13, probably afterwards. This is basically based on a lot of common iPSC differentiation studies across almost every protocols. They have different days of differentiation. This is almost covering all these protocols. Okay, then if you walk through from the top to the bottom, you will see different protocol variables or features classified by different categories. For example, from iPSC cell lines, coding matrix, cell-cell interaction, seeding density, cell medium, and the supplements, and then move to differentiation, for example, assessment of this cardiac purity, different methods, and some other studies use these DIFT human iPSC derived cardiomyocytes for additional maturation strategies using different techniques, and then to assess this maturation of these cardiomyocytes. Typically, they focus on different physiological aspects of these cardiomyocytes, including physiological maturation, metabolic maturation, and morphological and electrophysiology, calcium, etc. So finally, once we produce these high quality human iPSC cardiomyocytes, so people will use this for different purpose like disease modeling, drug discovery, right? So this will be listed at the very bottom of this database. So this typically covers almost every aspect of human iPSC studies, from development biology to disease modeling to drug discovery. So later on, we can use this database for different purposes, like Nathan mentioned, comparing ventricular versus atrial cardiomyocytes, or comparing omics data or versus non-omics data, or comparing different disease modeling, or use this database to find the best protocols for different disease, for different drug discovery targets. A lot of things we can do based on a very generalized protocol database. So here, please, Chris, please move to the circulation paper. Once we give people a lot of trainings, we will send through a couple of list of these very famous papers. So you can use these papers to find this information, right? So here we take a circulation paper as an example. This paper is focusing on mTOR signaling and how this signaling inhibition blockage promotes maturation of human iPSC-derived cardiomyocytes via a certain p53 induced quiescence pathways. So basically, you see these keywords. Okay, this is on mTOR signaling, and then how they mature this, how they promote maturation of these iPSC carriers, and then via what mechanisms, right? Normally, in the beginning, I read through these titles, abstract background, aims, and the results and the significance or conclusions. Just give yourself a very brief concept of these studies, and then I will just jump into the methods part. Please, if you can scroll down to the methods, the same PDF file. Yeah, perfect. So here you can see a very compact methods part listing from, for example, cell lines, differentiation of stem cell to cardiomyocytes, right? Bear in mind, a lot of journals, they only give you a very compact version of methods. So sometimes you have to revisit this link to find the very full version of these methods. To save you guys the time, this paper I have already downloaded the full version of these methods. Please, can you move to that? Thanks.
Do you mean the supplementary?
Supplementary material, yeah. Normally there will be a separate PDF file.
So just to add on to that, so usually you would have the methods in like the method section in the website, but often because of the complexity of these experiments, they will put it into something called a supplement, like a supplement file or supplementary. So this means that you, in circulation, you will have to click this link, but in other papers, you might need to search it like the way that I've done earlier.
Yeah.
So if you click on this link, that will lead you to install this file called supplemental methods.
Yeah, perfect. Some journal they just put this supplemental information of these links to the bottom of these studies. All right, so if you can see these supplemental methods from cell lines to differentiation, right? So normally in the cell line part, so people will describe clearly on what iPSC line they were used. For example, how many iPSC line, what are they, and how did they maintain these iPSC lines during maintenance stage, right? And then move to differentiation. So they will just use this maintain iPSC line to a certain protocol. So in terms of this paper, so I will pass the head-to-head technical data curation to Chris Cho. So make sure there is no conflict between the computational curation and the technical location.
Amazing. So let's just change the audio so it's just
Yeah.
a bit clearer.
Yeah.
Just mute.
All right.
And
And finally, if you have any questions, just pop up to our group chat or just directly provide.
okay, thanks, Nick. Testing. Could someone reply with thumbs up if you can hear me? Great. So in your like your meeting control, there's a react button. If you have any questions, just click that and do some emojis, and Nick will be monitoring for questions. So he will stop me whenever we need to. Okay. So I guess to just add on a bit, um, I would like to explain why we selected this paper in particular. Because first of all, this paper focuses on maturation of cardiomyocytes. That is a really key thing that we're trying to achieve. In the introduction session that we had earlier, I've showed you that right now our stem cells, like our cardiomyocytes, the stem cell derived cardiomyocytes, they haven't reached this adult value. And circulation itself is a really high impact journal in cardiac biology, which is comparable to Cell Nature Science papers out there, but specifically for cardiac, its impact factor is around like 50. So we decided to select this really high quality paper to do an example of the protocol curation. Now, noting that in reality, when you process other protocols, it's going to be a lot harder because of how maybe there are missing details or so. So we're going to do our best today to try and explain the difficulties in processing these kind of data. And I want to show you some key AI tools that we can use to help assist us with this if you're not too familiar with, if you don't have any background in stem cells at all or biomedical science. So to kick this off, right now I have on the right, I have this Excel spreadsheet, which is the protocol data. It's the first draft of the protocol data we're going to fill in. The way it works is that this data is designed to capture most information, all information, if not everything, most information, if not everything, in terms of the protocol design, so that we can do further analysis. We can write algorithms and some code to see if we can link these variables into a better format that can be suitable for machine learning. Right now, this data is only designed to capture most information. So here we have a key, in terms of this data format, there are two columns here that we will not, that are not, that you can just like feel free to change it however you like. In particular, this notes column is not processed by our algorithms. What that means is that you can type anything you want here, and this will not be processed. So this is going to be a really helpful note-taking place for you to just type any notes. And I'll explain why we need that later. So first of all, we have the IS, the cell line. So on the left here, you can see that this study uses three different cell lines. So to do that, I will just put that into notes for now. And that is just to serve as a reminder for myself to check in that later. And then I'll move on to there. And I'll see something like overall passage number for each cell line was less than 70. So that is currently a missing protocol variable, and we will have to add that. But just to give you an example, if you see something that's really important, let's say like a cell line that is not available in this data, then what you can do, imagine BJ is not here. You can right click other parameters and then press insert. And you can copy the cell line that you have into this position. So yeah, I hope that is helpful to understand what's the purpose of the nodes. And another important aspect of this is that sometimes you will have three different cell lines. And in this case, we actually want three different sheets because each sheet should report one single protocol only. And I'll keep on explaining why we want that later on. I'll just keep on moving with this for now. Okay, coding matrix. So if I keep reading on this passage, I see the cells were maintained in stem flats. So I know that that is a media already. But when I was starting, I had no idea what this is. So one thing that I can do is to copy these sentences and paste it into ChatGPT. Coding matrix mentioned in this. So that is a really simple way to just confirm that I cannot fill in any of these for now. So one simple way for me to remind myself is to perhaps change it into another color so then I know that I need to revisit it later. Then I'll keep on moving on from there and look at this part. I can see that they were placed at a density between 20,000 to 80,000. So I'll just copy that and try and find for something called confluency. So now that is based on experience, right? But you can literally just put in the notes here and remind yourself you need to fill that in later. I will keep going on and try to find the media. And I start to see something related to that. So it was changed from stem flats to RPMI B27 on day zero differentiation. So looking at our database, for simplicity, we have only started from the start day of differentiation. So that is day zero, which means that the media before day zero was stem flats, but then starting from this day is RPMI. So I'm going to go to cell media here and I'll try and find for RPMI, and indeed it is in there. So I could do this in two ways. I could just like type the notes, or I could try and go here and find RPMI. And I want to know which day it was used. Nick, does it mention the day?
So yeah, it's a good question. Sometimes in the methods, once you get a full reading of these methods, you might get the information.
Mhm.
But sometimes even you get a full methods, you still can't make sure what window they used. But don't worry, later on you can go back to the main figures. Sometimes you can find in the main figure, for example, the figure one, the schematic figure, they just list the protocol in terms of what day they put what of these supplements or the medium.
Amazing. Yeah. So what you would do here is that although you know that this is RPMI, you don't really know which day it is. So you can literally just make a note and remind yourself to revisit it later on. So moving on from there, I will keep on looking this. And then I'll keep going down, and you'll see a category called supplements here. So now I'm focusing on this part. So one way that I can do this is to literally just go back here and copy all of these. Read this paragraph and say that I'll even call this paragraph B. And then I could do this. I will just copy all of the supplements and say this is a list of supplements. Tell me if any of them are used and whether there are other possible types of supplements. The text that is not included in the list. So right now you can see that I'm really just generating them immediately, but you can save these kind of prompts if you find them helpful, and then you can just literally just be using them again and again. So ChatGPT has told me there's B27. So what I'll do is I'll copy this. I'm not just going to blindly believe in it. I'll just go back to this part of the text and I'll search for B27 and search within this paragraph. So I can see B27 was actually used starting from day 0. So I'll go back here, look for B27. Starts from day 0. And then I can see Chiron. This is also a very common one. Chiron was started at day 0 to 2. And there's actually a concentration provided. So I want to use this 6 from this. And then IWP. And then 5 day 2 to day 4. And then insulin is right here. Now imagine if we didn't have insulin. What I would need to do is to go down here at the bottom. So ideally there will be other parameters here. We're going to fix that before we send it to you. And then we'll insert a new row and then we'll type insulin. And here we're going to do 10 UG per ml from day 7. Okay, so I'll just stop here, but you can see that there are actually other supplements that were used. This is also a supplement, pretty common. And I'll just stop here and check my database. So I know that I need to revisit this coding matrix later, but just based on this information, I could, let me skip the cell line for a bit. Unknown day. In terms of putting this into the right side where we're going to process the data, the algorithm that we're going to write doesn't check against what you put in. Instead, it checks against what is not in the dataset. So it checks for something that's empty rather than something that's there. So you can literally put in anything within these, and the algorithm would think that this protocol variable is used in day 1. So we need to be pretty careful in terms of not putting everything in, like not mistyping something here. And the way it works is that we know that B27 starts from day 0. We're going to assume that it goes all the way to the end of the protocol. So we will do something here, putting a T here, and we just drag this all along to the end, depending on what was reported in the paper. Another example here is that we know that Chiron was used from day 0 to day 2. So first of all, we need to go to the right side here in units. And then we need to put in, so I'm working on this row. I'll put in UM. This is not the actual symbol, but as long as you use something that's conventional, I will be able to process it later on. And since this is day 0 to day 2, I'll put in 6 here, and I'll just drag this across these three. Then I'll move on to the rest and focus on these guys. So this one will be 5, starting from day 2 to 4. Nick, am I doing this right? So I see there's an overlap between the values here.
Yes, because sometimes they just, for example, change another medium on the is exact the same day, right? Just overlapping between these two different molecules. One is an activator, the other is antagonist.
I see.
Yeah.
So what do you suggest here?
So you just put exactly what the
Day.
paper did.
Okay. So yeah, so this will be the correct format until we design a better format. So you can see that this is why protocol data can be pretty limited in terms of how we represent them. And then we keep on going to the end, and then we have insulin. So starting from day 7. So I'll put 10 here, and then I'll just drag this onwards, pretending that it goes to the very end. And then I'll put in UGML at the very start as the unit here. Okay, so I think I've done a good example here, trying to explain how you put in data into the database. Another tool that I want to highlight instead of ChatGPT is Notebook LM. So Notebook LM is a tool developed by Google. It is a really useful AI tool that you can also use for your other studies. So I'll go through how you open it with you right now. You just search it in Google for Notebook LM, and then you try Notebook LM. I'll paste this in the chat as well if you want to skip the process. Okay, so I'm going to go into the bottom and click Create New Notebook. And since we have already installed the PDFs, in this case, we have the supplementary file here and also the manuscript file. And I'm going to drag it into Notebook LM. And then I can pretty much ask it some question. Now, remember we haven't decided what the coding matrix is. So I can focus here. If you have knowledge in stem cell protocols, you will know that these starting days, maybe up to day 7, if I'm right, will be differentiation.
And based on most iPSC studies in this field, most protocols will be between 12 to 20 days, let's say 2 weeks, 15 days for the differentiation stage. And then later on, they harvest these iPSC carriers for different purposes like purification or assessment of this purity, and also for the future, for example, maturation strategy and for different research purpose.
I see. So yeah, so I can start to ask, what do you think is a good cutoff date? Day 12?
Day 15
Day
normally
15.
is a good
Okay.
cutoff date. Oh, here I just provide another top-up point. So you will know, Chris made some situations like a lot of these features you don't know exact the window of this, right? So don't worry. So normally when you read through the whole method, you still have no idea. In this context, you need to go back to their
The
main
figure.
figures. For example, if you can open the main figure 1, normally panel A, This will be a schematic protocol listing how long they used the protocol and in what specific window. For example, the medium added, the supplement added, so a small molecule added. Yeah, like this.
This one, right? So I'll revisit this point later, but this is a really good point. So going back to the notebook LM, so we haven't decided what the coding matrix is, right? So a simple way, so the difference between notebook LM and ChatGPT is that notebook LM does not hallucinate. It doesn't create fake information for you. It will always answer based on the PDF you have provided it with. So I can ask it, what is the coding matrix or material to grow these cells on? Particular, was there a change after, before, and after differentiation? And you see, it will give you back the like kind of an answer. So you can just check about the references and see if that is valid. Another way is to try and copy some of these terms that were being used. So I can notice gel traps and gelatin. And where is it? Here. So I'll see MTF as well, which is in alignment with this. So therefore, I can go back to the database and you can see that sometimes the same reagents or the same material or media reagents can have different names. So sometimes AI is a really good helper when you check against existing entries against the database. What I'll do here is drag this to the side, and I see gel traps here. 30 min.
Chris, sorry, give me a second. So you will see here, because normally in human iPSC cardiomyocyte studies, they have two different stages that can use coding metrics. The stage one is for iPSC differentiation. You have different coding metrics, right? And the stage two, once this human iPSC can be differentiated to cardiomyocytes, people will harvest these cardiomyocytes for additional replating for research purpose. So make sure you can identify this coding matrix is under differentiation stage or replating stage. If you are not sure, just put some notes here.
So that is why I put a note here and haven't added the date yet, because in this paragraph it doesn't really say which day it is, other than it's like a seeding thing. So this is probably differentiation if I'm right, but you have to make some guesses like this.
In my opinion, this is probably after differentiation.
After
Yeah,
differentiation.
they just harvest this iPSC for additional maturation strategy, and then by seeding them on another material and then coding these metrics.
Yeah, thanks, Nick. So this is a really good example because you can see that even for even for PhD students, you have no idea what's going on in this paper. So this is a moment where you need to make a clear note here. Instead of doing 30 minutes for room temperature, I would actually go back to this part and say on page 6, page 7 mentions it, or something better, use ChatGPT to polish this up. And then what I would do is actually just send a message to Nick to ask him what this means.
Sometimes you can
Yeah.
read through the context. For example, if you just move to the next row of these gel tracks, you can see iPSC derived cardiomyocytes, right? After completion. So then you will know, okay, this is just for replating stage, not iPSC differentiation stage.
Yeah. But again, like Nick is super friendly. Just message him if you don't know. So I'm going to go back to the figure example here because we haven't decided which days, for example, like the cell media was used in. So Nick was pointing out that although the test does not describe it, a lot of the information is actually in the figures as well. So which is why I'll go back to this manuscript figure, uh, which is pretty much the website. So I'll use the website. And then I'll go to figure 1 here. And you can see that our database format was redesigned to be similar to these illustrations here. And you can see that stem flats is the media that was used before day 0. And starting from day 0, we need to go to RPMI. And it starts from day 0 to day 7. And moving on from there, RPMI is still used from day 7 to day 18. The only change is that the absorbic acid was changed to insulin. So which means that the whole protocol lasts to day 18. So I'll put a T here and just drag this all along to day 18. And in this case, if you know that the protocol ends here, you're more than free to delete stuff. And this is also a point here. If you're very sure that nothing is being used, you can delete the rows or columns. And similarly, you can see there are other supplements being used at different time points. Yeah, I think that's it.
Pretty much like this.
Yeah.
Yeah.
Do you guys have any questions for me? Oh wait, I do have one more thing to add. So this is a good example where we have filled in a good chunk of the data. Ignore this true here. And then I'll try and delete some rows so then it's more clear to you guys. It's not compulsory. You don't have to delete anything. But if it's going to be helpful when you process it, you're welcome to do it as well. You know what? I'll just go to the top, delete everything. Okay. So now you have a clear idea of what the whole protocol looks like. There are a lot of other variables that we have not covered today. And we will do that later on in other training sessions. And we will do a recording as well. And based on this protocol, you see that there are 3 different cell lines. Something that I'm particularly interested in, and it's not exactly covered today, but I'll just point it out, is that you can go to some of the findings of the study. There'll be probably in other figures. For example, you can see that in this figure, while we have added, we haven't added taurine. Let me just add one. So in the database, there's also one called taurine. And then let's pretend that this is 10 during this period. Now you can see that in this protocol, top right, the authors actually publish a few results. So in an example like this, depending if this is an outcome that we are interested in, there are some specific outcomes such as contractility, some of the maturity aspect that we've discussed before. I would like to have a few options. So I know that there's 10, there's 200, and there's a control, which is probably the one without anything. And then I'll just need to put in a unit here again. I know it is nanometer. Based on this information, I will need to make 3 copies of this spreadsheet. The first one, the control is going to have nothing. The second one is going to be 10, and the third one is going to be 200. So you can see that this kind of grows exponentially and it can get pretty complicated. So that is why we have future training sessions to help you cover what is needed, like which kind of protocol variations are, like we need to document them and which are not. Because for this same data set, you will have to do it for other cell lines as well. But just building on experience, like please reflect to us how hard things are. And in this case, me actually doing this protocol, I realized that I need to make, if I have three different cell lines, I need to make nine total spreadsheets. And that's, you can imagine that grows exponentially if I have another variation in another variable. So in this case, I'll probably write some code to just process this information. Then I know that there are particular cell lines are being used. Um, I also deleted some of the lines, but you're not supposed to do this. But you're also like you're supposed to look at this note and find, for example, we'll do something like this for simplicity. So yeah, that is one way to do it. The only downside here is please do not change. I think I've done a bad job. Please do not do it the way I've done it, because we want to try and use the original entries in the date in this column. So then we'll be able to match the protocol variables pretty effectively. If you do this, an example is the original entry was BJ rips with no hyphen, like no dash in between. So now in terms of the algorithm, it'll be pretty hard to determine that these two are the same thing, especially if there's an extra space bar here at the end. So yeah, I think that covers the whole section. Do you have
Yes.
anything to add, Nick?
Yeah. Like Chris mentioned, so you may know that today we only focused on differentiation stage, giving a very comprehensive of later on post-differentiation studies, including a lot of maturation strategies, molecules, physiologies. So we need to find another time, let's say next training, to explain what are these physiological parameters. So then you will get a sort of step by step learning from stem cell consortium training. So you can understand. So we will have more exciting trainings upcoming from next stage.
Yeah, awesome. Feel free to ask any questions, guys.
One question.
Mm. So Lily asked whether we need to take notes of how you have used AI or ChatGPT. Right now, we haven't decided on that yet. I'm thinking of a strategy here where I would have a little survey, perhaps. It could be a Google form, but it will be a really quick, short one where I'm going to ask you a simple question. It could be, okay, let me try and do an example. An alternative way to do this is I will ask you to rename. This will be called survey. One way we could do this is in this template form that we're going to send to everyone. I will have some key questions here, such as what is your confidence in interpreting the paper? And I might have a drop-down box here that allows you to select from, 1 to 5. So we will have a little survey here that is going to be not too hard, 1 to 5. And with that method, it will act as a metadata that will allow us to do some, um, you can imagine that there might be a few of you working on the same study, and I will do some cross-validation analysis to see like the accuracy of these things. Because Nick has also got a reference that looks like this. He did it on the last session. and we'll get a sense of how well your confidence correlates to the accuracy of the data. You might be able to document any notes here, like extra notes. So yeah, we are kind of figuring out what to do along the way. So if you have like suggestions, like Lily, you have asked a really good question here.
Wow.
We want to do some further analysis on that.
Okay, there is another question I can answer.
Yep.
From which saga? Okay, this is a very excellent question. So bear in mind, this database is not the final one. So later on, we will revise a very most updated version to a member. So before day zero, as we mentioned, this is iPSC maintenance stage. This is also very important for human iPSC studies, right? So later on, we will put this part in our database. So you will see later.
So the purpose of today's database is kind of a simplified version. There will be a lot more comprehensive information up here. And you can see that one way to do this is simply to add some day minus days. And also note that not all protocols explain what they do before they differentiate the cells. Not all of them explain what they do like during the stem cell stage. So it could vary quite a lot. The idea here is that we're trying to provide a general format, and then we will have some guidelines on what to do, such as you need to add a new column. But I reckon we might just do the columns. But yeah, that's something to
We
discuss.
can add more columns.
Yeah. And we would also do something like this because we are also hoping that this is not just like pure data curation, but an opportunity for everyone to learn about stem cell differentiation. I, for one, have no idea what's happening at all. So something like here, I imagine we will have something, say minus zero. We will have something like a merged cell here, and we will call this maybe stem cell.
Stem cell maintenance, stem cell culture.
Yes, I got it right. I guessed what he wanted. And then you have this stage,
differentiation,
estimated differentiation stage. So through this process, you might come along some of the terms like differentiation, and you start to get a sense of what it really means. And something like maintenance, like you could have a stage here called maintenance. It means that people went on holiday, like during Christmas. They have done differentiation and they don't want to do the experiments anymore. So they just sit there, let their cells sit in the fridge, the freezer for a while, for maybe a month or two, and then they come back after the holiday. Imagine they're doing like a month. And then they would come back, thaw the cells. That's better, right? Anyways. And then you will have the actual maturation of cardiomyocytes. So that protocol could look something like this. Yeah, I hope that answers your question. Any more? Those were amazing questions, by the way.
I noticed the time is already 6. So because we don't want to overuse students' time for this meeting, but if you have any questions, just email to Chris Chow or me. And remember, we also previous send you guys email including the stem cell paper, right? And then associated with most current database, you can try
Give it a try.
do the data curation, use stem cell paper, and then once you complete it, just send that through to Chris Cho, and then we can provide a specific feedback to you.
Yeah. So the idea about the stem cell paper is that you don't have to fully complete everything. Just give it a go and have a play, something like this, and see along the way if you encounter any questions, and then you have a better idea of what we are doing, and I can like answer any issues you have. And just to add on that, in terms of next step, I'm going to make a Teams channel. So it would be amazing if everyone could install Teams. And we're going to start communicating on Teams. I will invite everyone who has joined this session and the last session, and we can literally just communicate on there. So if you send me protocols, like you can send me something like this, but you can literally just focus on ISP cell line, IPSC line, and maybe supplements, and you can pretty much ignore everything else. If there are multiple combinations, you can like there's no reason you can't just take a note here and just be done. You don't have to make multiple sheets at all. The idea is to just gain some familiarity, and then you can ask us questions along the way.
Yeah. A quick answer to Lily's question. So actually, we don't have a due date for this practice protocol, but if you could just have a try within 2 weeks, when your brain is still kind of freshing, so that we can just provide feedback to you.
Yep,
So
that's it.
no stress, no pressure, just enjoy this building.
Yeah. So we'll have a Teams channel and then people will send stuff as they go. You can literally just do nothing and see what other people are doing and learn from their experience. So yeah, let's end this meeting. And if you have more questions about AI or creating this data, just feel free to test me over Teams. I'll just make a group thing so we can chat.
Thank you, guys.
Okay,
Thank you for going
we're
through.
gonna stay here for a while and you guys can just leave. And if you are feeling shy, you can just wait until the end and ask questions. Bye guys.
See you.
Yes.
Yeah. If only the English then how is the information captured?
That's a good question. So, let me share my screen again. So this really comes down to how we design the code to process these databases. Because if we do this right, we're going to get thousands of Excel spreadsheets. Now, you might think that that's a lot of data. Compared to genomic data, that's nothing. But still, you need to be pretty clever in handling this kind of data. And my main worry here is that, so I've created data before, which is why we have come up with this way better design. So the issue we had before was, I think the example I gave was a nice one. To understand this, you will have two different entries which are the exact same thing, but there is a minor difference between them. Now, the computer can't tell that these two are the same. There are ways to do this. We are thinking of using some large language model as part of this study, but that really depends on. So we have a collaborator in University of Melbourne, and they are pretty eager to help us a bit with this. So there's ways to do this, but for simplicity, I would just okay. Now that I've explained, there's a like the problem with incorrect entries. When I say we are checking for empty cells, the problem is that some students might be using this. They might be using true like this. They might have misspelled it. Some might be using a T, and some might have a 20, but then there's an extra blank behind it, blank space. So in terms of when we read the file might think that this is a text instead of a number. So a lot of these issues would confound the analysis. So to answer your question, how are the empty cells analyzed? The the algorithm that we are using, I planned for it to detect empty cells to make it null, like false. So I'm not checking if this is true, but I'll simply check that this is false. So the algorithm would think that this is true and this is also true. And I will have a second layer of algorithm that checks if this is a number. It will try and clean up that number and check what the concentration is. And I will have another layer of algorithm that tries to check against the units because different studies have different units. It sounds really stupid. And Nick actually gave me a really good example as well. Like in the high impact journals, because they do so many experiments in one study. Let's say you're measuring contractility here. Oh, this is amazing. Nick has already included it. So you have contractile force as two different units. And let me tell you, these two units are not interchangeable. One can be, this is force, this is newtons. The other one is, what is this? Atmospheric pressure?
Pascal. Pressure.
Yeah,
and
atmospheric
using
pressure.
different methodology.
And another study can be using electric activity like impedance or something. And these units are not translatable to each other. You can't simply just apply a formula and change the units. So issues like these make it pretty necessary to have a unit column here. So you will do something like this, and we have a third layer of algorithms scanning for these units to ensure that all of the units are comparable. And we're really trying to just build a massive quantity of protocols such that we will reach sufficient power in most of them. In our earlier study, CM Portal, we roughly had, for let's say contractility, we roughly have 50 studies, and that was sufficient enough to get power. But still, the more studies, the better. And that's what we are aiming for here. That was a great question. I keep asking those.
Very
Yeah, don't be shy.
computation.
Ask it like in front of the group so the whole group can learn from it.
Okay. I took a while to type it out. Thank you.
Yeah, okay. See ya. Bye.
Yep, see ya. Bye. Thank you.
I'm starving. Go away.
Thank you, both. See you later.
Bye bye. See you.
Bye.